Hello everyone, welcome to 2 Minutes Coding, and today we'll be solving detect a cycle in a directed graph. It can be solved using two methods, the BFS or the DFS. Today we'll stick to method number 1, which is the DFS or the depth first search. So for this, I'll just do a dry run of the code and then explain the intuition behind it. So using dry run, let's just keep two things with us, which is the visited as well as the path visited array. Okay, we can start with any source. Let's start with source as 0. So visited of 0 is true and path visited of 0 is true. Then we go to move to 1 using the DFS. You know how the DFS works, I hope. So I'll just put a pen. So yeah, from 0 it goes to 1. From 1 it can either go to 2 or go to 5. So let's start first with the 5. So visited path visited of 1 is true as well. So next let's go to 5. So visited of 5 is true, path visited of 5 is true. Now from 5 we can't go anywhere. So we'll come back to 1. So we'll remove 5 from the path visited. So it does not exist in path visited anymore. So from 1 we can next go to 2. From 2, we can next go to 3. From 3, we can go to 4. And from 4, we finally come back to 1. Now, here is the catch. You see that 1 exists twice in the path visited array, or if you're just choosing a simple array, you can say that the path visited of 1 is already true. That means there is a 100% a cycle detected. Okay. Now, that is the basic thing that we need to do in this question. Now, you might ask, why do we need a path visited array? Why can't we just do it with a visited array? Imagine a case 1 goes to 2, goes to 3, and there's another node 4 which just comes to 2. 2 would be already visited when the DFS travels from 1 to 2, 2 to 3, and then we go from 4 to 1, 4 to 2, I mean. 2 will be visited, but it would not be path visited because this will be a new path and not the path which we followed earlier from 1 to 2 to 3. That is why you need the path visited array as well to make sure that you are not just giving fake cycle detections. Okay. Now, just for the time complexity and space complexity, the time complexity of this question is big of number of vertices plus number of edges, and space complexity at max will be of all the edges, all the vertices were in a cycle. So the worst space complexity would be big of e. So yeah, that's it from my side, guys. We'll see the BFS solution in the next video.